Hey everyone, this is Monique Mazerel. I'm working with the University of New Brunswick in St. John to create some webinars and peer-led tutorials on how to do certain parts of medication math. So today we're going to be focusing on weight-based dosage calculations. And I can't stress enough how important weight-based dosage calculations are, as a lot of times when we're doing them, we're drawing up medications for a pediatric population, and that's something that you don't want to get your math wrong on. That can lead to extreme med errors and extreme adverse events for these patients and even mortality. So we really want to get this down pat. So we're going to start off nice and slow, but we're going to go through different questions and different steps to do these med math. So our objectives today are to accurately convert weight to calculate the prescribed medication that we're administering to our population and calculate the minimum and maximum safe dose range. And this is an extremely important thing to do. We need to be able to have that extra safety net, per se, to make sure that we're giving the right amount of medication to our population. Very important. So let's look at some things that we're going to have to do when we're performing these weight-based calculations. So the first thing we're going to have to do is probably convert weight. Most times the weight is in pounds, it's not in kilograms. So again, I just want to remind you that 1 kilogram is 2.2 pounds. So you're either multiplying or dividing depending on which unit you have to go to. The next thing we're going to do is calculate our dosage based on weight. We're going to do our drug dosage administration calculation. So, okay, we have to give so many milligrams, but how many mils do we have to drop, or how many tablets or capsules do we have to give? And the next thing that we have to do is assess if the dosage is within the safe range. So the safe range, if you've never heard of it before, is a minimum amount of drug to give per day and also the maximum amount of drug to give per day. So when we do our calculation, we have to make sure that the dosage that we're giving is within these two means. We don't want to give more, we don't want to give less, we want to give it within that safe range. So let's start right out. So Lasix is ordered for a child who weighs 16.5 pounds. The safe dose range is 1 to 2 milligrams per kilogram. So the first thing that we have to do, as you can see here, is what's the child's weight in kilograms. So we know that the child weighs 16.5 pounds. So let's draw that out, 16.5 pounds. And we want to go to kilograms. So we know that this is a smaller number. We could just divide it by 2.2, but I'll draw it out for you so that you can see that I'm canceling out the units. So we know that there's 2.2 pounds per 1 kilogram. So when you do this math out, you will see that the child weighs 7.5 kilograms. And this is really important. We need this weight. We need it because we need it to calculate our safe dose range. So to do that, we know that the safe dose range is 1 to 2 milligrams per kilogram. So the 1 is going to be the minimum safe range, and 2 is going to be the maximum. So let's do that math here now. So the minimum, so we have 1 milligram per kilogram. So when it says per kilogram, you can draw it over top like this, and it can help you cancel out the units so you can kind of see what you're getting. So we know that the child weighs 7.5 kilograms. So that's where we're getting that number from. That's why we did that first, because we need it to calculate the safe dose range. So if you do your math here, it's pretty easy math for this one. You know that the minimum safe dose range is 7.5 milligrams. So that's the smallest amount that we should give per day. So to do our maximum, we see that the maximum here is 2 milligrams per kilogram. So if we're going 2 milligrams, like I said, per kilogram, we're multiplying it by the same amount with the same weight, 7.5 kilograms. And we do our math, our units cancel out, which is lovely. We know that the maximum safe dose range is 15 milligrams. So whatever we're giving, because this question doesn't have all of it, because I just wanted to start it off and show you a little bit of conversion and figuring out that safe dose range. Whatever amount of drug we give, it has to be between these two numbers, the maximum and the minimum. Very important. So let's move into a little bit of a tougher question. Okay, this is a long one, so let's read it out. So Sadie is a 14-year-old with severe asthma. She has a chest cold, and her doctor believes that she may have developed pneumonia. So following a chest x-ray, her doctor indicated that she needed to be placed on Zithromax. So Sadie weighs 116 pounds. So that's really important. Let's underline this. Her doctor prescribed Zithromax 8.5 milligrams per kilogram PO once a day, so we'll underline that as well. And the supply is 325 milligrams per 5 mil. The safe daily dose range for Zithromax is 7.5 to 15 milligrams per kilogram. So we have a couple questions that we're going to go through. So first off, what is Sadie's weight in kilograms? Because we always have to start off with that. We need that unit. The second question is, what's the volume of medication that Sadie would receive in a single dose? So we're going to be doing some drug dosage calculation. And what is the safe daily dose range for Zithromax? Is she receiving the appropriate dose? And that's, the biggest thing that we have to look at. So, okay, there's lots going on here, as I said. So let's go back, look at the question, see what we've come up with. So let's start with what we know. Sadie weighs 116 pounds. We know that. It says it right in the question. So prescribed and desired, if we're doing D over H times Q, we have 8.5 milligrams per kilogram. So that's how much we want to give her. We have our 325 milligrams in our 5 mil, so that's our have in our quantity, and then our safe range is 7.5 to 15 milligrams per kilogram. So let's do some questions now. Okay, so first off, most importantly, what is Sadie's weight in kilograms? So just like I drew it out on the last one, I'll do it again. 116 pounds. And we know that we're looking for kilograms, so we have 1 kilogram up here is equal to 2.2 pounds. So when you do this math, you're going to multiply it all out, and your answer is going to be 52.72722. Okay, but we want to round to the 10th position because this is the weight that we want. So we know, too, it's not going to round up, that Sadie weighs 52.7 kilograms. And this is the weight that we're going to be using to do the rest of our questions. So, okay, I've added it in up here. I'm trying to put in everything that we have. So Sadie weighs 116 pounds, which is 52.7 kilograms. Prescribed desired, 8.5 milligrams per kilogram. We have 325 milligrams in 5 mils, and our safe range is 7.5 to 15 milligrams per kilogram. So the next thing that we want to do is we want to know what volume of medication would Sadie receive in a single dose. That was our next question. So we have to start off with figuring out how much medication we want to give first. So we are going to say, because we know that it's 8.5 milligrams per kilogram, that's how much she's going to be getting. So we can write this out, 8.5 milligrams per kilogram. Like I said, if it helps you to write it out this way so you can cancel out your units, it's a great way to do it. And we know that she weighs 52.7 kilograms. So when we do this math, we see that we are going to be giving 447.95 milligrams. So we can't give 0.95 of a drug. We got to round it up. So doing our rounding, this is going to be 0. Going to add 1 here. We are going to give 448. Oops, that's not an 8, that's a 4. 448 milligrams. Okay, so that's great. We know now how much the dosage is, because before we just had our 8.5 milligrams per kilogram, but now we actually have the amount of milligrams that we need to give. So next, we're going to figure out the volume of medication to be giving. So this is going back to drug dosage calculations. If you haven't seen those, I have some other videos on them. You might want to check them out. So that is we're going to be using our formula. So our formula is D over H times Q. So this is desired. So now we know what our desired dose is. We know it's 448 over have. So we have that right up here times quantity. So it's 5 mils. All right, so let's calculate that out. So we want to give 448 milligrams. What we have is 325 milligrams times 5 mils. So when we draw this up and do this math, we find that our answer is 6.89 mils. And with this, if you watch my other videos again, we know that when we're drawing up something that is greater than 1 mil, we have to round to the 10th position. So we're going to round this up. We know that we are going to be giving 6.9 mils to equal 448 milligrams. So I'm going to clear this, and I'm just going to write this out one more time, just in a little bit of a different way, because some people don't like the D over H times Q. You can just cancel out your units. So 448 milligrams times 325 milligrams over 5 mil. And again, the answer is going to be the exact same. It's just a different way of doing it. 6.9. I could draw my point in there, mils. So that is the next part of the question. So let's move on and figure out our safe range. So let's see, what are the safe range dosages? So again, I've written in here like the minimum and the maximum. So let's do that math. So the minimum safe dose range, and also I've added in up here how many milligrams we want to be giving, because we want to make sure that we have that on hand so that we can know if our dose is appropriate or not. So the minimum is 7.5 milligrams, again, per kilogram. Okay, and we are multiplying this by her kilograms, which I forgot to write in up here, 52.7. So we are doing 52.7 kilograms. Again, we want these units to cancel out. They're going to cancel out. So the minimum is going to be 395.25. We're not going to give 0.25 of a milligram, so our answer is 395 milligrams. So this is our minimum. This is our minimum. So let's do our maximum now. Same thing, just different numbers. So our maximum is 15 milligrams per kilogram. We're multiplying it by her kilograms, which is 52.7 kilograms. And our answer is 791. Oh, well, it's 790. So I was rounding it too quickly. 790.5. And again, we're going to round this, so it's going to be 791 for our maximum. All right, so now we know that SAIDI has been prescribed and we are giving 448 milligrams. So this is definitely within this range. It fits right in between there. So we know that it's a safe dose to give. I know a lot of people can look at this and say, well, we're giving 8.5 milligrams per kilogram. That falls within the safe range dosage of 7.5 to 15. But the thing with these is, as I said at the beginning, is that this is super, super, super important math to get right. So this is your backup. Doing the safe range dose, like that is your backup, and it's something that's super important. So this is just the first step. I'm going to have another video doing another example for a weight-based dosage calculation, and I hope that you tune in if you need the help.